Astronomers have found that the vast donut-shaped clouds that surround supermassive black holes at the center of galaxies are lumpy and irregular, rather than smoothly formed. But the reasons for the uneven shape remain a mystery. The experts believe it may be caused by turbulence generated by the black hole as it devours material, or the energy given off by young stars stirs up turbulence which percolates through the cloud. Another idea is that clumps of matter falling into the black hole cause the disturbances. Supermassive black holes are thought to lurk at the center of most galaxies, possibly all, feeding off a rotating torus of dust and gas that surrounds them. The black hole at the heart of NGC 1068, 47 million light-years away in the constellation Cetus, also known as the Whale, is around 15 million times as massive as our Sun. The torus shape explains why some black holes are hidden behind gas and dust, while others are not. It depends on whether we view the cloud edge on or face on. When the astronomers from the University of Southampton turned the space telescopes to NGC 1068 and measured the X-ray radiation coming from its center, they were surprised to find the black hole suddenly brightening. Although this was a single event, study author Poshak Gandhi told Mail Online that multiple brightenings and dimmings have been seen before in other galaxies, so we know that their tori are also lumpy. This hints that the lumpy torus phenomenon may be common in the universe, and supports the so-called unified model that explains why some galaxies appear very different from each other based solely on orientation. Professor Gandhi estimated the radius of the inner edge of the donut to be about 0.3 light-years, or about 1/10 the distance between the Sun and Alpha Centauri. We think it is perhaps 10 times this in thickness. Commenting on the fact the cause is still a mystery, Professor Gandhi added, "We'd like to figure out if the unevenness of the material is being generated from outside the donut, or within it," said Professor Gandhi. New Star gave us a fleeting glimpse of its black hole through the clouds, allowing a better test of the unification concept, added Andrea Marinucci of the Roma Tre University in Italy, lead author of the study published this week in the monthly notices of the Royal Astronomical Society. How big can a black hole get? Scientists believe that supermassive black holes may lurk at the center of all galaxies, but what sort of sizes can they reach? According to Professor Andrew King, an astronomer from the University of Leicester, these gargantuan galactic sinkholes could reach as much as 50 billion times the mass of our own Sun before they run out of steam. In a paper published this week in Monthly Notices Letters of the Royal Astronomical Society, Professor King explained that once the black holes cross the size threshold, they disrupt the rings of gas which settle around them. While these disks feed the black hole, they are unstable and can crumble into stars. Professor King's calculations showed that once a black hole reaches 50 billion solar masses, its outer edge stops the disks from forming, depriving it of a food source and stunting its growth. The researcher explained, "The significance of this discovery is that astronomers have found black holes of almost the maximum mass, by observing the huge amount of radiation given off by the gas disk as it falls in. The mass limit means that this procedure should not turn up any masses much bigger than those we know, because there would not be a luminous disk. Bigger black hole masses are in principle possible. For example, a hole near the maximum mass could merge with another black hole, and the result would be bigger still. But no light would be produced in this merger, and the bigger merged black hole could not have a disk of gas that would make light. One might nevertheless detect it in other ways, for example as it bent light rays passing very close to it, gravitational lensing, or perhaps in future from the gravitational waves that Einstein's general theory of relativity predicts would be emitted as it merged.